Welcome to this lesson on solving inequalities. Today we're going to talk about how to solve addition inequalities, subtraction inequalities, multiplication inequalities, and division inequalities. Alright, so when you're solving addition and subtraction inequalities, it's the same process as when you're solving addition and subtraction equations. The only difference is now you have an inequality symbol instead of an equal sign. And it doesn't change the process at all when it comes to adding and subtracting in inequalities. It will change the process when we talk about multiplication, but we'll get there soon enough. Alright, so here we have g minus 2 is less than or equal to negative 8. So I add 2 to both sides. I have g is less than or equal to negative 8 plus 2. I know that when I do that, I have g is less than or equal to, I take 8 and subtract 2, and I get 6. Since negative 8 has the larger absolute value, my answer is negative 6. So g has to be less than or equal to negative 6 to make this inequality true. So let's take a look at that. Let's put in negative 7. If I do negative 7 minus 2, does that stay less than or equal to negative 8? Negative 7 minus 2 is the same thing as negative 7 plus negative 2. And I get negative 9 is less than or equal to negative 8. So that is not true. So since it's not true, I know that my solution works, because the second that I used a number bigger than negative 6, my inequality wasn't true. So as long as I use any number smaller than negative 6, it will be true. So then what I'm going to do is we're going to practice graphing our inequalities a little bit, and you graph this solution. So g has to be less than or equal to negative 6. So g can be anything that is smaller than or equal to negative 6. So I have 0, negative 2, negative 4, negative 6. So it can be equal to, so I have a closed dot, and my arrow goes to the left. Okay, again, it's subtraction, so I'm going to add 9 to both sides. P has to be greater than negative 9 plus 9, I know is 0 because of the additive inverse. So P has to be greater than 0. It cannot include 0, so I have an open dot, and P has to be bigger than that. So I'm going to highlight everything on this part of the line. Right, and then we can double check. Let's use 8. 8 is smaller than 9, so if I do 8 minus 9 is greater than 9. 8 minus 9 I know gives me negative 1, and that makes this not true, so I know that my solution works. And anything that's bigger than 0 will work. And actually, I did that backwards. I didn't do it backwards, but this is negative 9. So let's make that make more sense. 8 minus 9 is negative 1, and negative 1 is bigger than negative 9. So my number was bigger than 0, so it worked. Negatives, they trip us all up, don't they? So let's put in a number that is less than 0, because that was the solution. There we go. Negative 1 minus 9, is it still greater than negative 9? Negative 1 minus 9 is like negative 1 plus negative 9. Is it greater than negative 9? This is negative 10. Negative 10 is not greater than negative 9, so it's not true. So the second that we used a number that was smaller than 0, this inequality didn't work. See, that's why it always pays to go back and double check your work. So here I have b plus 22 is greater than negative 1, so I subtract 22 from both sides. I'm left with b is greater than negative 1 minus 22. So I can change this to b is greater than -1 plus a -22, because minus a positive is the same thing as plus a negative. And it's just easier to do because now it's a negative plus a negative. So I have b is greater than -23. Right, so I'm going to put -23, -21, -19, so on and so forth. So it's not greater than or equal to, so it has to be an open dot, and it has to be greater than -23, so my arrow is going to go to the right. Here I have plus 4, so I'm going to subtract 4 from both sides. I have k is less than or equal to -7 minus 4. So k is less than or equal to -7 plus a -4. Since they're both negatives, I can just add. So I have k is less than or equal to -11. Right, so here I have -10, -8, -6. So here's 11, and it can include 11, and it has to be less than or equal to 11, so my arrow has to point left. Okay, and I've solved all of these inequalities. Now remember, what this is saying is that there's not just one solution, because these aren't equations, these are inequalities. So there's infinitely many solutions. We're just saying we're giving ourselves a better idea of what we could use for k. So in this case, I want to know, well, what could I use for k and add 4 to it and still stay below -7? Well, I know that I can use any number that is less than or equal to -11. That's what you're solving here. So you can use anything below that -11 to keep this statement, original statement, true. All right, so it is extremely important to remember when you're multiplying or dividing by a negative number, the direction of the inequality symbol has to flip. Okay, so if you need a second to pause, write it down, because you need to remember that, and we're going to go over why that is. So we know that when we look at our rules, so if I do 48 divided by 12, it gives me 4. But I know a -48 divided by a -12 gives me a +4. I know a -48 divided by a +12 gives me -4. And I know that a +48 divided by a -12 gives me a -4. So when I change my positive and negative signs, it changes my outcome. So let's take a look at this in terms of an inequality. So I have -48 divided by x is greater than or equal to -4. So I'm going to multiply -48 to both sides. I'm left with x, and now if I leave my symbol the same, I know a negative times a negative gives me a positive. And actually, we did this incorrectly because we put the variable in the wrong spot. So instead of going through this all incorrectly, we'll fix it and make it a -12. There we go. And we're going to multiply both sides by -12 and -12. And I have x is, let's leave the symbol the way it is, greater than or equal to 48. Well, now let's put 48 back into that inequality. So 48 divided by -12. Is that still greater than or equal to -4? Okay, well, in this case, it is still equal to -4. So let's try 49. So I'm going to use 49 divided by -12 is greater than or equal to -4. And I get, and let's just do it as a fraction to save some time, negative 4 and 1/12 is greater than or equal to negative 4. Well, now I know since I added this 1/12 to it, it's further down the number line. So if this is negative 4 and 1/12 is like right here. And since we're going left in the negatives and getting further away from 0, we know our numbers are getting smaller. So now this inequality is no longer true because this is not bigger than negative 4. That's why the inequality symbol has to flip, because of the fact that you're changing the sign of the solution. So here we had a negative, and since we multiplied by a negative, we changed it to a positive. So because of the fact that we changed that sign, we have to change the inequality because now we're dealing with a different side of the number line. So let's get some practice on these. So I have x times negative 6 is 108. I'm going to divide both sides by negative 6. I'm left with x is, and I have to flip my inequality symbol because of the fact that I'm dividing by negative 6. So if your divisor is negative, you have to flip it. Now, we don't have a word for when it comes to a specific part of a multiplication problem. They're called factors, and neither one of them is different from the other. So you have to know whether or not you're multiplying by a negative number. In this case, we can say the divisor is negative 6. Since it's negative, we flip the inequality sign. Negative 6 goes into 108, so 6 goes into 10 4 times. And you get 4 left. 48 is 8. Positive divided by a negative is negative, so you have x is less than negative 48. So from here on out, I'm just going to plot two numbers so we know which way the numbers are going, just in case. So negative 48 and negative 46. It cannot include 48, so it has to be open, and they have to be less than 48, so it would be all the numbers to the left. Here I have x divided by 3 is less than or equal to negative 15. I'm going to multiply both sides by 3. Now, I know that this number is negative. Even though that number is negative, the number I'm multiplying by, so right here, and I'm actually going to change the colors of these, that number that I'm multiplying by is positive. So since those numbers are positive, I do not flip the inequality symbol. So I have x is less than or equal to negative 45. So again, we'll put negative 45 and negative 43. It can include 45, so we have a closed dot. You should be much better at drawing straight lines on your paper. This is a lot more difficult on the computer. Make that as neat as possible. And now if you take a look, so let's say we put in negative 44. Or no, we want it to be, yeah, so negative 44 is greater than 45. So if I do negative 44 divided by 3, okay, I get 3 goes into 4 once, and I get 1 left, and it goes into 14 4 times. So I get negative 14 and 2/3. Well, negative 14 and 2/3 definitely is not less than negative 15 because we're working with negatives. Negative 14 and 2/3 is bigger than negative 15 in negative world. So again, I know this can be confusing. We just have to keep trucking along and keep practicing. So here I have division, so I'm going to multiply both sides by negative 7 and multiply by negative 7. In this case, the number that I'm multiplying by is negative, so my inequality symbol does switch. And I get 4 times 7 is 28, carry the 2, 8 times 7 is 56, plus 2 is 58. A positive times a negative is a negative. So I have x is less than or equal to negative 588. And we can just go ahead and put negative 588 on our number line. And it has to be less than or equal to that. So it's a closed dot, and it points left. Okay, so divide by 9, x, and we didn't divide by a negative number, so we keep the inequality symbol the same, is less than 13/9. In order to make it a little bit easier to graph on a number line, we'll say x is less than 1 4/9. So we're going to go with, let's see, let's say this is 2, 1 8/9, 7/9, 6/9, 5, 4, 3, 2, 1. So this would be 1. And then this would be, because I don't have the smallest pen here, 1 1/9. Each of these is worth a ninth now, so 1 1/9, 1 2/9, 3/9, 4/9, 5/9, so on and so forth. X has to be less than 1 4/9, so 1, 2, 3, 4. Open dot because we can't include it. And our arrow goes to the left. And we're done. So it's okay if your number ends up looking like a fraction. Okay, as long as you have the solution at the end and you plug it back in and it works, you're all set. Now, here's the thing. I can plug in any number that is smaller than 1 4/9. So I could plug in 1 3/9, and it should come out less than 13/9. That's what that is telling us. All right, so you have some U-try problems. I only gave you 2 of the adding and subtracting because I believe we have some pretty good practice on that with equations. And then I gave you 1 of each with the multiplying and dividing with and without negatives. If you have any questions, be sure to email me or write them down so we can go over them in class.